Hello, and Dr. Ron Eaglin here with Module 4, Questions with Answers. How to do the calculations. We're just going to solve a number of sample problems to help you know how to solve problems. So the first one we're going to start with is relatively easy. Straightforward equations. Calculate the present worth of 9 annual payments of $800 each with an interest rate of 8%. Well, that's pretty straightforward because that is simply a P over A. So a few ways you can do this. One is just take each of those payments and then convert them, as you can see right here, using the 1 plus I to the n. In this case, you'd be dividing by 1 plus I to the n, the actual payment. And that's going to go ahead and give it to you in the present. And if you add all those up, you've got the present worth. That's it. Of course, you can also use the P over A formula. So P over A, this is this guy right here. And with the interest rate of 8% and 9, I usually just write out the calculation in Excel. It's right here. The formulas. Okay, P over A would be this guy right here, 1 plus I to the n minus 1 over I times I plus 1 to the n, which is exactly what this guy here would give you, which, by the way, gives you exactly the same answer. So that's just simply taking an annual payment and converting it to present worth. And guess what? The next problem I'm going to show you is just doing the exact same thing, but converting to future value. All right, different interest rate, different number of payments, payment. Now, I can do the exact same thing here. I can take each of those individual payments and calculate the future value of those payments. Payment number 8, future value will be, well, exactly what the payment is. Okay, and then I add all those guys up. Total number of payments that you actually made were this, but the future value of all those payments, because the payments made in those early years are worth more than their actual the value that you have the payment itself in its future value. And voila, you've got the answer to this. So if you were to look at this budget of $243,000 per year over 8 years with an interest rate of 13%, you would expect to get the $3.1 million that I am showing right there. What else can you do? Well, it's annual payments, future value of an annual payment. Okay, I mean, of course, you can always look it up from the book, slow, have that calculation ready to go. In this case, it is 1 plus I to the n minus 1 over I. Pretty straightforward, pretty easy. Which, by the way, when you calculate the payment, 243 times that factor, okay, that's going to give you exactly the same answer. Okay, pretty straightforward. And if I were to go and say, where is that equation? Well, there it is, F equals A, so F over A, the 1 plus I to the n minus 1 over I. Exactly what I did there, or I did it by using just all the payments of each of those years. All right, let's do another one. Need a little bit more complex as we go along. Highway department expects the cost of maintenance for a piece of construction equipment to be $5,000 a year. Then it increases $5,500 a year for that payment year 2, and it's going to go up by $500 a year through year 10. It's gradient. Interest rate 10%, 10 years of maintenance. So we now got a G, a gradient amount. That's $500. So if you looked at this, what would happen here? Well, the first year, that $5,000, you can calculate the present worth of that $5,000 pretty easily. Then you add 500 to that 5,000 in year 2, and the present worth, by the way, just happens to be the same because 10% interest, $500 gradient, it would be the same number. No magic there, just math. Okay, as we work our way down, you're going to take all of those present worths and add them together for $42,168.51. What else could you do here? Well, I could calculate the present worth of the gradient. There's an equation for that. Okay, linear gradient series. Okay, that's the worth of the gradient is this beautiful equation right here. Not really that hard. I plus 1 to the n minus I times n minus 1 over I times quantity I plus 1 to the n minus 1. Okay. Each of those factors, well, in this case, oh, did I not calculate here? I actually just did the calculation straight up. Hang on here. I'll take this B5 out so you can actually see the factor. Okay, it's 22.89. It's not $22.89. And then this, so let's make that a actual, let me format that cell so it looks a little bit nicer as just a number. There you go. And by the way, we actually would like to see a little bit more decimal places. So it's a number. Let's go ahead and give you 7 decimal places. That'll be sufficient. And this would then be equal to this number times, and the gradient number would be this guy right here. Either way, the sum, notice I got the same number by adding in the gradient and the actual annual amount because it starts at 5,000. So there's that 5,000, and then the gradient's calculated separately, the 500 plus. Put those two together, and voila, you have the same number. See what I did here? I took the P over G, got the value of the gradient, the base $5,000, got the value of that, and added the two together. Not magic. 4. This gets a little bit more challenging here. We got Ryan. All right, back to question 4. This one actually has a few ways to solve it. I'll slide this baby over so you can see it. The way this reads with the annuity whole thing here, now, he borrowed $15,000 at 7% interest. He pays it back over 7 years. How much is he going to owe in year 7 is what we're really asking. How much is he going to owe in year 7? All right, well, first thing you're going to do is figure out, okay, he's not planning on missing the 4th payment, so let's first calculate what his payments will be. All right, that's A over P. We know the present value is 15,000. A over P is that good old equation, A over P. I can go down here and go, well, look at that, A over P, which is actually just the inverse of this guy, P over A. Hey, inverse is A over P. Amazing how this math works. A over P, so his payments are $22,783.30. So if you were to make all these payments, okay, and we calculate the present value of all those payments that he made from years 1 through 7, it add up to $15,000. That's the same amount that he borrowed. Again, it's not magic. And if we actually just calculated how much he owed every given month as he went through and made the payments, it should zero out at the end. Okay, that's basically a mortgage amortization table. Okay, what do? You calculate the present value of that payment and you subtract the actual amounts from this 15,000, and you just do that over and over again. Basically, take the interest, okay, add the interest, subtract the payment. Adding the interest is just calculating the interest from the previous year, which is 1 plus I times that value, and then subtract the payment, which is this amount over here. It's not that hard. And you should get this amortization table. Well, problem is he missed a payment. What can we do? Well, there's a few ways to solve this. Let's go over here. One thing you can do is create this amortization table and just zero out year 7. And the number left here is going to be what he owes. So at 15,000 and the first at times 0, okay, what does he owe next? Well, you're going to take the value here, you're going to take the previous value times the interest on that value, which is 1 plus I, minus what he paid. And you get this number. And then you just repeat it. Now the interest is going to be, in this next one, the interest is going to be on the previous one minus what he paid. Now, if you take this guy out, notice that number goes up and then starts going back down again because he missed a payment. It went up because he missed a payment. 3409.66 is what he's going to owe in year 7. There's another way to solve this. if you really want to have fun. First, calculate the present value of the first three payments. 1, 2, 3. These are the guys I put in brown up here. That comes out to be 73,025 because what I did is I added these three. This is just summing up these three guys right here. Or I can just do P over A, same number. Now, a little bit more challenging on this second one. I want to know the present value of these 3 years. But what I did is I actually used the same 3 years, bringing it to year 4. It's going to be the same amount, but that's at year 4. This is the value at year 4 of the payments in years 5, 6, and 7. Which, by the way, has the same exact concept of the payments in 1, 2, and 3 at 0. 5, 6, and 7 at 4. Okay? Now, I got to take that 4 and I got to shift it to 0. How do I do that? Well, that's 1 plus I to the n. Not hard. Divide by 1 plus I to the n. So that 7304 is actually has a present value of 5572.38 because the 7304.25 was at year 4. Add these two together and I got the total present value of all the payments. Okay? Whoa, amazing. Same thing as adding in these 3 plus these 3. 12, that's the exact same number because I did this by adding up those 3. All right, but that's the present value of the amount owed. That's what he's lacking as a present value. However, he owes it at year 7. So what's the future value of this present value? Well, that's just 1 plus I to the n times the value. 3409.66. Okay, magic. 3409.66 is what we calculated the other way. And 3409.66. This was just going through a little bit of logic. Get the present values of all those payments. Get the present value of what he owes. Convert that to a future value because he owes it in year 7. Challenge. All right, there's another one here. Engineering company just purchased a CAD software for $8,000 and annual payments of $500 a year for 6 years. Starting 2 years from now, though, for annual upgrades. Well, we want to know the present value of that 6%. Well, one thing you can do is just put all those payments and just get the present value of each of those payments and add them all up. It didn't ask us about the initial $8,000, and that's just a red herring anyway. All right, what else could we do? Well, we could find the present value of all the payments, including year 1, okay, which is this number here, and then subtract out year 1, which is this number right here. And again, it gives us the same number because actually we just did the same thing. If we put that other one in there, that 471.70 would just be sitting here, but we need to take it out. That's it. Hopefully you followed my logic because it's not about the numbers. It's about how you solve them. Okay. The annotation P over A, P over F, P over F over P, F over A over F, and A over P. Those are the ones. Those are those equations. There they are. They're not, again, these aren't really hard equations. You can do this. That's it. Have fun with some of the homeworks. I got some challenging ones in there for you. They ought to look pretty familiar to you now, though.